There are several math standards we're going to explore, the first being numbers and operations. Numbers and operations can be broken down into several different areas, including counting, one-to-one correspondence, quantity, operations, comparison, writing and recognizing numerals, and place value. I'm going to talk about each of these briefly. In thinking about counting, we've all seen that children begin counting quite early by memorizing numerals. Oral counting can begin as early as 2 years of age. Children can memorize the sequence of the number words just like they can memorize other words, but they often miss portions of the sequence. This is challenging for children because they don't understand, it's hard to understand numbers as functioning as a group rather than as an individual item. So as children increase in age and reach the preschool years, they can develop greater accuracy in counting, and they begin to tag an object by pointing to it as they count them. They can have difficulty keeping track of what they're counting, but they begin to start realizing that there is a one-to-one correspondence between numbers and objects. So as children progress in years, they develop greater accuracy to count to 10 and begin to see the patterns for decades, such as 10, 20, 30. They need to learn that the patterns after 1 to 9 is that they then need to take a decade like the 10s, 20s, or 30s and also add individual numbers to them. At about kindergarten age, children can count collections of objects, obviously at least to 5 and hopefully beyond 5, and they begin to count on. So they might count a group of 5 objects, and then when a new one is placed, they'll know that that object is number 6. They won't have to go and recount the entire group. Beyond knowing the number words in a sequence, counting requires children link a single number name with one object and only one at a time. This is known as one-to-one correspondence. Many young children simply recite the counting sequence as they touch items, with no real awareness that each item corresponds with one word in a counting sequence. It may seem that they know their numbers and what they stand for. However, when we listen closely, we might find that children do not grasp the concept of counting, at least not entirely. They sometimes touch more than one item when they say one number, or conversely, they say several numbers and touch only one item. In fact, children's verbal counting often seems to not have great relationship at all to the number of objects that they're counting. So to count correctly, children has to keep track of the number of items that they've counted and making sure not to count twice. Young children often count an object several times to get an accurate result. Despite having consistently used the correct verbal sequence, they need to develop the skill in one-to-one correspondence. Enumerating the objects in a set is central to understanding numbers and operations. When children realize that they can tell how many objects are in a set of items by saying the last number in a counting sequence, for example, counting 1, 2, 3, 4, 5, 6, there are 6 cups, they've begun to understand number quantity. To develop the concept of number, children should have experiences with representing quantity in a variety of ways, such as 10 frames, dominoes, dice, tally marks, finger patterns, and many other representations. One of the basic skills in developing number sense is having experiences with recognizing part-to-whole relationships. For instance, children need to understand that the number 7 can be represented in different ways, that it can be represented with a 4 and a 3, 5 and a 2, or a 6 and a 1. They need to know that any whole number can be represented in parts. This is an important precursor to number operations. The part-whole relationship helps children develop an understanding of the relationship between addition and subtraction that they'll need in later schooling. Once children have a good sense of numbers, they'll begin to engage in operations. The easiest number operations are problems that are active in nature and can be solved by very young children. The two most common are adding and taking away. Teachers can best ask a question or pose a problem that's related to children's real-life experiences, and this will motivate children to think about the use of numbers and operations in solving simple problems. For example, you can ask a child to count the number of pieces of candy they got in their Valentine's box, and they can say 1, 2, 3, and then you can say, well, I have one more. How many do you have now? And that child says 4. By adding one more, this was something that he really valued. It served a purpose for him, and it was functional, and so he was motivated enough to solve the problem. Research suggests that children in all cultures follow a simple 3-step developmental progression in solving operations problems. First, they count all the objects. For example, when adding 3 apples to 4 apples, they first count the 4 apples one by one, and then they add the 3 more on, reaching 7. The next is that they count on. In other words, they already know that they have 4 apples. They can look at a group of 4, understand that it's 4, and then they can count on the 3 additional apples, 5, 6, 7, to reach the end result. And finally, they perform the necessary arithmetic in their heads through mental representation. Perhaps they manipulate objects in their heads, or they might actually have memorized the answer. And this is the beginning of using operations to solve simple problems. Next, we'll look at comparison. Comparison terms are important in children's mathematical development. They're using language like more than, bigger than, greater than, less than, smaller than, fewer than, the same as, are invaluable to children when relating 2 or more numbers. It's common that children will have difficulty using language of comparison because it's important that when comparing numbers, it's more than just knowing the right words. They need to understand these number quantities that are associated with the words. So while one child might say that 100 is bigger than 10, which is true, another child might say 100 is many more times than 10, understanding that it's not just a larger number, but it's a much greater number. So really having a conceptual understanding of numbers is necessary to both compare quantities in general and then to begin to assess specific number relationships and understand numbers and their differences a little more closely. To progress in math, children need to be able to use the standard written numerals of their society. In the U.S., of course, this is Arabic numerals. There's a certain parallel in learning the symbolic representation of numbers to literacy. During early childhood, children are learning to recognize letters of the alphabet, and at the same time, they're constructing their understanding of key skills and concepts that are basic to literacy: the alphabetic principle, phonological awareness, structures and patterns in language, and so on. So similarly, during the same period of time, they're building an understanding of numbers, and children should be learning to identify and use numerals, in addition to understanding about number quantities. When children learn to recognize and write numerals, it's important that teachers constantly describe the meaning of the numerals. Equally important, teachers should listen to children as they use their words to describe the meaning of the symbols that they write. Researchers propose that the number symbols should always be accompanied by some form of representation for quantity whenever possible. Certain things like a number line, using different sorting materials. The particular representation really isn't important. It's the fact that there is a representation there is a critical part. In writing numbers, it's important to consider that this is a fine motor skill and requires a certain amount of muscle control and copying ability. Again, just as in early writing activities, children need to practice writing numerals in many different media. They should do what's most comfortable for them at first. They can create numbers first by using clay, writing in shaving cream, shaping them out of pipe cleaners, and then they can begin to trace numerals in things like sand and hair gel and move forward slowly by adding writing utensils. Finally, we have place value. Understanding our decimal system requires that children recognize the place value of digits. It's important that they recognize that a 12 is not the same as a 21 and a 56 is not the same as 65. At the heart of the decimal system is the exchange principle that 10 ones equal 10, 10 tens are 100. So in the early years of children's development of mathematical thinking, they start by learning the number names, and they'll even do this for 2- and 3-digit numbers. However, this is only the beginning. It's not enough that children know that 25 is a 2 and a 5 together. What they need to understand is that that number symbolizes 2 tens and 5 ones. So children really need identifiable benchmarks for 10 and 100 that they can grasp confidently to really understand our decimal system. Naturally, this begins with 10 fingers, but there's many other options. There are 100 pennies and $1. There might be 20 children in our class. It's really important that children find as many ways as they can to learn to represent place value so that they have a really great grasp of the 10 system.